Hello, hello, hello. Welcome to another stream. Yesterday I had some plans in the afternoon and Thursday. Oh yeah, I did something for my fiance. So we skipped a couple of streams. But we're back. And let's get right into it. So the goal for today is, can we get this edit to work? Maybe not in the most performant way possible yet, but at least that we changed the huge octree accordingly. And then we go from there. There's a couple of things I would want to think about first, though. If it makes sense to do that now, the edit, or if we should do one small, but one refactor first before doing that. Because currently we have no way that this is one mesh, right? So even if we generate the octree or change the octree, we need to regenerate the whole mesh, which is like insane to do. So probably we should do the chunking now before doing the live edit. Because if you can see, that's like 500,000 triangles or like vertices. Is that the vertex count? I think that's the vertex count. And then if we go to view, mesh viewer, then we can see that this is like one huge mesh, right? Which is probably not the smartest way to do this in like the long term. And anyways, as well, not like how I planned it, but it was the easiest one to get it working. So I'm thinking of, how big is that? It's from, no, okay, from here to here. So it's 500 512. Yeah, that's 512. So I would say assume this is 265, right? 256. One 2048 minus 256. Yeah, okay, yeah, it is. Ah, I mistyped, but 248. Yeah, okay. 256, and then this one is 64. Okay. In that case, I think we will do. If I do calculate 512 divided by programmer, divide by 1 shifted by 9. That's 1, really? That's 5. Oh yeah, because it's 512, of course. Yes. 1 shifted by 9 is 512. Alright, so that doesn't work. But 64 divided by 512 would be good enough, right? I hate it. Maybe I should try to get used to the other calculator that we recently got. Yeah, okay, so that works. And I think we can store 10 levers, right, in that key. But even then, it doesn't matter, I think. For what I want to do. The size. Yeah, I'm not sure what the best size would be. But let's do 512 for now. So the idea would be, let me plug my phone because it's almost out of battery. That we do store the leaves, well, that leaves, the chunk leaves more or less in one list, and they go at maximum to depth 512. And each of those stores its own mesh buffer. And then we do that. One thing I want to know as well, actually let's try that first. Because I'm curious why the mesh is so weirdly positioned the way it is. Where do we do that? In the shader. That is a little bit weird for me. Open resend that one. And then let's get rid of the sphere. I just want to get the lane. That should give us a 21. Of course not, because it's a shader header, so we need to clear our shader directory. Maybe I will actually address that this week, because that's kind of annoying. Is that actually the temp directory here with the logs? Okay, yeah, that's always just the last session, which is nice. All right, so let's start that. What's happening? Okay, yeah, so that is this, and I think I would assume render doc that this is, it just took so long for the shaders to compile, right? Yeah. All right, let's take a sample first, because I would want to see the 21 vertices. Maybe we filter out duplicates? Would that help? Ah, no, because we don't have an index buffer, right? But we have like this triangle, which makes sense, and then we have this triangle, which doesn't make any sense. And at that point, nothing good can come out of that triangle, right? And we have this triangle, and then we have another degenerate triangle, and then we have this, another degenerate triangle, this. Why do we have so many weird triangles here? Let's try to get that fixed first before we move on. Because that would be kinda interesting to understand. So for that, let's output how many vertices we have here. Do we really? I mean, probably that is 21, right? That is probably just 21 vertices here. It's an int, right? U or D. Vertex count 7. Okay. One, two, 3, 4. Hello, Capuchman. Let's actually print our vertices. X, Y, Z. Or that didn't work out. Is that, oh, like that probably. Then the rest should hopefully work. Hello, what's up? Welcome, welcome everyone. And yeah, sorry for not streaming, well, on Thursday. On Friday I couldn't because I had plans, but yeah, Thursday I chose to do something that I promised already quite a long time ago. Okay, so this position is different. That is a little bit unfortunate. But I mean, that would probably be fine. And then probably here to here, and then here to here. Why is the last two positions the same? Yeah, sure, nice. The question is, can I make that easier? And can I somehow... I mean, with that, it's probably biased, right? Because we have... a lot more in the Z coordinate than we do in the... We should probably have those unique. Question is, how do we do that nicely? Maybe we have like a vertex list here. Where at most I think we have 32 vertices, right? Something like that. Odd components. Yeah, I think that's it. Now we have here a U and vertex indices. And then here we have as well U and line point. Well, maybe that's a vertex here, I don't know. Because I think we push this here. Actually, not really. Wait. So actually we don't need that, but then the line segment. How does that work again? We Put out outline segments. And then in the generate lines. Okay, yeah, I think we can leave that to be like that. This is like that. And then we do void add, well actually you and add vertex. We have an out vertex array of 32 vertices, and we get out a list of, well, and then an out u and vertex count, and for each if vertices at I, is there an equal glsr compare vec3? Vector relational functions. Where is it? Equal. But is that somehow reasonable? Or does it have floating point precision issues? I have no idea, let's try. So it's equal or what? That with the, or the vertex that we want to add here. If that is the case, we return I. Else we return vertex count plus plus. Oh, well, we need to write it. Add vertex count plus plus equals u and index is vertex count plus plus. I think do we have the debug feature here? No, right? I don't think so. Don't have the debug print here, but it's fine. So we do that, and then in the components, we have a vertex count here. Where do we add? Here we copy them, right? So basically it would be out vertices dot add vertex. That. Now we get an index out. Where? Oh. Vertex count. Like that, right? And then we do the same here. Just with that, I don't know, probably the same, I have no idea. We copy it there. And now we do the same here. Yeah. And then that's that. And now we basically say okay, I mean, yeah, that kind of sucks. So that would be out vertices at this vertex indices. Vertex count. That might work. Or that is no, that is correct. That is as well correct. Perfect. Okay. And the only thing we need to change now is this one. Yeah, gets out that plus and out vertices of 32 and out u and out vertex count. And we basically initialize that with 0. And we have to always add that here, right? Oh yeah, and then here out vertices like that. That's the actual call. All right. And then here, oh, we have one too much copied here. Okay. Maybe. We can generate here. That is that, u and vertex count is like that. Now we do this and vertex count. Which I'm not sure if we actually need, but whatever. I'm not sure if we need the vertex count. But we basically go... That is basically the same. That is the same, but here we do out vertices, add vertex indices. Like that. And then for this, do basically the same thing, but now we skip vertices that we already have. Look at that. I mean, those are the same, right? Vertex indices. Not sure, sometimes it allows me to do that, sometimes it doesn't. Here it did again. I'm not sure why. But okay. And then here, basically I would only want to count the unique vertices. Page end? Yeah, true. I always forget that. True, true. No, it's yeah, it's end. Yeah, I knew what you meant. Don't worry. So how would I do that? Because I can't really do unique list here, right? That doesn't exist. I mean, let's first see if that even works before we do anything. Like that and like that. Then vertex indices. We probably didn't do that everywhere. Yeah, already we didn't do it. Yeah, probably I did some mistakes somewhere. Yeah, as expected. 31. Cubical marching squares, 31? That's a bit bizarre, but okay. Oh, where? No, it's not bizarre. Let's actually make that like that. I don't know. Okay. Hey. Oh. And equal vertices. Normer. Which I think was the case, right? Yeah. Yeah. So they are pretty much the same. That's good. Wait, is that... Oh, is the equal... Ah, that returns a Boolean vector, okay. So I guess I would need to do an OR then. I mean, is that really more performant than just I have no idea. Yeah, I'm not sure either. VS Code is really annoying in that sense. Or like the other way around, yeah. I don't know. 360. Oh wait, that's in cubic or margin squares or what? 360. Eh? Expecting a comma. Oh. God damn it. $406. Okay. 406. Well, that is garbage what I did. Yes, you are correct. I have no idea why I did that and why I thought that's a valid thing to do. What looks ugly? $407. Yeah, it does. Yeah, it does. Oh. Vertex indices. The question is, can't I do just that? Because I mean, I'm doing the same thing in the other cases where... The only question is, does this equal maybe to like epsilon comparison? Which would be better. Because it would be a little bit safer, but I mean, we could do that in shader code as well. We could add a almost equal function ourselves. Okay, so we have that running again. I assume everything should be the same. We should still have the 21 triangles. It should still be misaligned. 24? Oh, that's bad. That's not how it should have ended up. How did I do that? Eh? What? 8,000? Okay, I mean, that's the... But how did I end up with more now than before? Or maybe we are not... Maybe this component thing is wrong. Where is it? No, I am officially a little confused how that would work. We reset the vertex count here, which is correct. And that one we don't return, right? Because that one stays the same. Unless I did something weird here. I don't quite understand what I would have done wrong. So I mean that one is pretty much the same. And the only question is, what do we do here maybe? Segment index, line point index. Traced segment, line point index. Traced segment, line point index. And then here as well. Traced segment, line point index. So the only thing I could imagine is that this is wrong suddenly. But why? I mean, actually, it would probably be enough to compare the vertex index, right? Wouldn't it? Because that means it's the same vertex. If I'm not mistaken. Okay, so that still works. Do we get a nice 21 triangle now again, or? $24, but why? Is it suddenly more than before? I am so confused. Which ones? It's a bit weird as well that... Wait, we have this a couple of... What? We have this a lot of times. That's the same triangle. 3 times? Really? Here, here, here. And now we have again here. That doesn't sound right. Why? And why was that not a problem before? The vertex count is probably still... Does it say here? Okay. Why does it not say the vertex count? Shouldn't it? Here? Vertex count 8. Before it was 7, right? But I mean, even then, those should be unique now, but maybe they're not. Or, I mean, okay, maybe not, right? So vertex index is our thing here. And then now let's, yeah, and then let's do the position as well. U int vertex index, where? Yeah, let's do index. I don't know. It's I. And then vertex. Y, Z. And then it would be this. I mean, that's already better to read anyways. Let's keep that. It's nicer anyways. All right, so we have vertex index of 0, which is perfect. Not. Did I make a mistake here? Okay. Oh, wait, odd components. Okay, yeah. That is a problem. That's just a problem of this loop here. Alright, so now it should be better. Okay, yeah, 0, 1, 0, 1, 1, 2, 2, 3. I mean, that maybe makes sense. Although this doesn't really make sense. Thank you for the follow, Con Papas 9. Thank you, welcome to the stream. Hope you have a great Saturday so far. Okay, cool, sure. Does that make sense that we go 0 to 1 and then we go back to 0? That doesn't really make a whole lot of sense. And then we would go to 1 again, and then we go to 1. That's a little bit sus that we do this in terms of like, just the triangles are really scuffed in that sense with this. It works out. But is it really? God damn it, I hate my cable for the phone. It always connects and reconnects. But how do we optimize that away? Let me quickly open the another implementation of that from another guy. And let's see if he does anything smart here. So he has the triangles here. And if the size is greater than 4, then he does that. And then he has the actual size, which is weird that he does it like that, but it's fine. The question is, where does he add stuff to this vertices list? Why? I wanted to learn it mostly, and I think it's, I mean, maybe not, right? But I think it's more future-proof, but maybe not. I don't know. It was not really a like super conscious decision, I would say. It's just that, yeah, I kind of wanted to do Vulkan because I thought it's like nice and more, gets like more new features and stuff like that, but maybe that's not even true because OpenShell gets a lot of stuff as well still. So I don't really have a valid or like a super sophisticated answer for you. It was more like a matter of I wanted to try Vulkan. That's about it. There was not really a lot of sophisticated stuff going into it. Do I like it? Yeah, mostly I actually like it. I think it's that the learning curve is extreme. But I think it's similar to DirectX 12. That it's like, compared to DirectX 11 or OpenGL, DirectX 12 is as well a little bit more complicated because you have to set up way more stuff in advance. But once it's running, I think it's really nice. And I really enjoy Vulkan. What is this word check? You mean between DirectX 12 and Vulkan? Yeah, that's about what I kinda heard. He stores it per edge. I think that makes actually more sense. Because one edge can have only 1 point, right? So maybe we do that as well. We store it per edge. And then we get rid of that garbage stuff. But does that help me? I mean, kinda maybe. It kinda helps. If P equals 0. Otherwise we do this. Modify vertex finding to handle non-fully subdivided nodes and prevent vertex duplicates. Okay. Yeah, sure. Shoot away. I hope I can answer it, but I guess I probably can, hopefully. Let's see. It's not a fully done render graph yet, but it's 90 or like it's 80% there. Let's put it that way. Okay, no, let's keep that at 32. I don't know. All right. Is that realistic, the way of 32 vertices? I have no idea. It's fine, I think. But why? Okay, the other question is, why would we have like so weirdly shaped triangles? And does he do anything about that? With the size or something like that? Doesn't seem like he does something specific for it. Do you declare all your passes up front and then start with nodes that have no dependency? Build a tag. Okay, wait, I need to read that slowly. So do you declare all your passes? So what I do is Yes, I declare all my passes up front. Render graph. Is it in init? I think it's init. Maybe not. I mean, I define the edges based on the resources. So it's kind of manual, but not really. It's it's by the nature of the render graph, right? I mean, it's kind of implicit, or like it's not implicit. It's kind of manually because you do like these nodes here, right? But it's all linked with those resource usages. And before I had the graph, it was really just that it used the same ID for a resource, and that's how it linked it. The same integer or string ID or whatever ID you would want to use. And then it linked them together like that, because you had like an in resource and an out resource, right? Always. And every in resource needed an out resource, and that's how you can build your directed graph. But yeah, basically it's this, and then I read all my nodes, I create all my nodes, and then I already have the order from the DAG, because I have my order already defined by the topological order of the graph, based on those links and like inputs output IDs. And then I go over all nodes in order and create their output resources, because inputs I don't need to create, right? I only need to create output resources. So here I create the output attachments. And then as well, that's a little bit untested, but I go over the inputs and decrease their reference count. And if I encounter a resource, for now it's only textures, that doesn't have any ref counts anymore, I mark that texture to be able to be reused by another output resource. So with that you can do aliasing of resources in theory, but I have not really tested that if that already works. And then once I have created all the output resources, that is basically just loading and creating the render passes. And shaders and stuff like that. So this is really just calling each node, say load your shader, load your render pass and stuff like that. And then it's basically done at that point. And the resources, I have a resource cache, right? So the render graph here has a resource cache. It's a little bit outdated. That's why I say it's like 80% done, because this was built before I had the visual editor, so it can be a little bit better now. But basically this is just a uint. It's the hash of the name. You can see here, for example, the swap chain, right? It's just the hash of the resource name. And that is really just a hash map of resource name as a uint, as a hash, to the resource. And every frame, this resource gets updated basically, if we need to. If it's not a transient resource, that can be just reused every frame, because we don't need a history or something like that. But for example, for the swap chain, we do it somewhere in the render graph. I think in the begin frame or something like that. Yeah, exactly. So here you can see that's a little bit ugly currently, but basically at the beginning of the frame, I get my swap chain. And then I say resource cache swap chain resource is this one right now. And the depth targets were, because those live outside of the render graph. So I update them like that. That is not how I would prefer it, but I didn't find a better way yet. Yeah, that would be nice. I mean, yeah. That would be cool, yeah. Just not sure. I mean, probably it should work, right? Because you have your frame index basically, so you would need, so you could know which swap chain image you would want to get based on that already. So it could work, probably, maybe, most likely. I'm really confused. How do we handle? Why do I get degenerate triangles and they just don't care about that, or? Because that's so weird. Why am I getting those weird triangles? Maybe we should add some more log. Do we have the debug print here? Not really, but we can add it. Includes. Let's see how many things we get here. Because that is maybe interesting. Maybe there is an issue with the way we build our stuff. Let's take that one. Let's go there. All right, so let's go here, and then we have here the segments. What I still don't understand is where the separate segment comes from. Actually. That I'm still a little bit confused. Okay, so let's do here vertex count, where component count, component that, and then vertex count like that, and then component index vertex count. All right. Component count. Do I not need to reset that? I mean, I guess we do it on here. It's fine, I guess. All right, whatever. And then do we want to? Yeah, let's debug print here if we remove stuff. Removing duplicate, start, end. Don't really care about how many here, I think. And then vertex line point vertex is that. line vertex, and then let's do percent f, percent f, percent f. Let's do u as the vertex index. And we can probably add that here a couple of times, so here as well. And let's do that here. Perfect. That should give us a I have a suspicion now that I thought about it a little bit more. What might be wrong. I'm not quite sure why I get more triangles right now. But that's a detail. It doesn't really matter in that sense. Alright, let's add that. Alright, let's actually get our log output from here. Oh, I didn't. Yeah, of course. Of course, I need to do this beautiful thing again so that we recompile. We ran out of buffer stuff. Buffer space for the log, but it's fine, I think. We will get an overview of it, I assume. Wait, that might not be what I wanted. Let's already do that because we need to save anyways again. And then it's probably I want to have the traced segment here. Segment percent EU as well. That is segment index here. And then because otherwise it doesn't really tell us anything about the segments. Perfect. So let's go all the way to the end, or not. Where did I have my beautiful... Okay. Did I close it or what? Well, whatever. Segment 0. Okay. And then we have line vertex 0. And line vertex 1. Why? Why is segment 0 and segment 3 the same? And is that really what we get here? Because that looks a little sus, not gonna lie. That looks a little weird. Damn it, where is it? Here, no, here. So we really have that many line segments or what? But that would mean that... Where does he remove duplicates in his version? Because I think he does that as well, right? Is that here? Yeah, kinda. I don't really care about that. Find face that shares edge with strip of current face. I mean, that's nice and so, but why would we have... Yeah, that doesn't really make sense in my head. Why would we have two? Did I compile? Well, we will find out. I guess I didn't. Why would we have two vertices with the same... two components with the same lines? Doesn't make too much sense in my head. Let's fix that first before... That might be the whole stream today, but it's better to fix that now than to have to deal with that later. Okay, so we really have 4 segments, which kind of makes sense because we have 4 sides that we need to do, right? But it doesn't really make sense that this is... how we would triangulate it. And no, actually it doesn't make sense. Those should all be... Okay, something is off here. How do we debug that? Probably generating here and then say face U, case U. And then let's do face index, ms case. Because it seems like we have like a face that shares the same thing, which kind of doesn't, like as I said, it doesn't really make sense. Did we not? Nah. I guess we didn't. Ooh. Let's actually close to the right. Can I close to the left? Of course I can't. God damn it. Or whatever. Why does it not output? Did I do something weird here? It should be here. And MS case is not 0, so we should output that. Can you please do that? Case? Huh? What the hell is going on? Okay, let's put it here. I don't know. Okay, we generated something new. Alright. What? What? But then we shouldn't generate anything. Are we not outputting that? Did I not only do that if it's ambiguous? God damn it. Alright, well that is unfortunate. That was an oversight. I think that I did that during debugging. God damn it. Alright. Well, we can still leave it like that. It doesn't matter. Alright, so let's see about that now. Five, 10, 0, 0, 12, 3. And it should probably be done. This one, the phase 5 that breaks it most likely, right? because this is segment 0, this is segment 1, segment 2, and segment 3. So phase 5 and phase 0 produce the same vertices. Alright. Let's do a couple more things then. Let's find the debug prints and let's remove a couple so that we don't run out of log space again. I think I could make it bigger. Whatever. Alright. And then let's see where that shenanigan is coming from by outputting here the corner 0, corner 1, corner 2, corner 3, and then let's do face corners 0, X, Y, Z. Okay, well, that's not what I wanted. No. Yes, that's what I wanted. So. Oh no, that's fine. Where? That doesn't work right. 1, 2, 3. 1, 2, 3. And 3, 2, 1. Actually, I probably want to put that here. So that is face index. And then corner 0, corner 1, corner 2, corner 3. Zero, 1, 2, 3. 0, 1, 2, 3. F %F. That should do it, I think. And let's generate, or let's keep that. Let's do this. And let's run that and see what comes out of there. A shader error, great. That's exactly what I wanted. 294. 294? Oh. That was garbage. Of course. All right, let's put that here. What do we have here? So phase 0 goes from that to that to that to that. That looks fine. And that's case 5. Good. Or alright, we need to probably do a little bit different than phase 1 is as well different. Okay. Let's do then a little bit more. Let's only do that if phase index is 0 or phase index is 5. And we do another debug print here. X chord, Y chord. Because I'm interested in that as well. That should give us a little bit more info, hopefully. So that's X and Y, Y and Z, and that is 0 and 1. All right. That I think makes sense. But why do the same vertices come out then? That is a little bit... Phase 0 and phase 5. Do they even share anything? Phase 0 and phase 5. Phase 0 and phase 5. I mean, not really. I mean, they share one edge, but that's about it. And phase 5 is Y and Z. That makes sense. Yeah, and then this is X and Y, right? Yeah. That was the thing we saw. X and Y, exactly. And this is X and, well, Y and Z. Which is correct as well, based on what this looks like. Because we have Y here and Z here. But maybe that's wrong? Maybe that's wrong? Or do we maybe not build it back together correctly? So we do all of that, and then we do the edge vertex here. Where we calculate the zero crossing. Where we get our corners. I mean, okay, I do understand that we would get the same, one of the same vertices, right? But both of them doesn't make sense. Because we basically got... Where is it? We are not outputting that anymore? Okay, where? But we... I do understand... Core stack. No, here. Phase 6420. 6... Where is it? 6420, right? That's the back phase. And then 6, 7. 6, 7. 4, 5 is the side phase. On the right. But yeah, that's a bit odd then. Because 3. Yeah, okay, that kind of makes sense. Because it would be those two edges combined. But then, yeah, I don't get it. Okay, let's add some more logs here. Where do we have more logs? No, not here. I mean, basically we take that. Let's not do that for now. That didn't really help at all. And we probably just have this case here, I assume. And then let's say edge, well, from vertex to vertex. I don't need that. All right. Let's as well do the edge from edge 0, not 0, to edge. Let's do that here, cube edge. Because that already annoyed me a little bit that this was buggy. Great. Do I spot my mistake or not? Oh, yeah. That was probably it. Maybe not. Alright, let's look at it. Oh, is it that? It's position. All right. Okay. Hello. I want to mark everything here. Thank you. That was painful. Okay, from this to this. Wait. Ah, did I write 2 times from? God damn it. I mean, it doesn't matter. But I think I did, right? Yeah. Doesn't matter. Okay, so this is the same vertex, yeah. Then we go to this position. Okay. So then why would you... Why would you say then this... Eh? What? Alright, now I am confused. Now I am officially... very much confused, because didn't you put in here that you did combine those in like a stupid way? What? Okay, let's remove the case because it adds too much. I think I should investigate how to increase that buffer, because that's actually a little bit annoying that it has so little space. I think it's just a constant that I have to set somewhere. But what can you do? Let's not output that anymore. Okay. Wait, why is that the same? So I mean that is the same as... Wait, am I outputting garbage? I think I'm outputting garbage. Wait, hold on. Line vertex. So I mean this is... Why would you consider... Those are the same. But it says here line vertex 0. Am I outputting something wrong here? Did I just trace something that's not even there? Did I make a mistake? Vertex index. No. Unless I do something stupid here. Zero and 1. And now we go in here. Because those two are not the same, right? Yeah. But then we go in here. And that should return 1, but it doesn't. It returns 0. Why? Segment 3. Am I doing... Out vertex count. Yeah. Do I need to mark that as in out? Is that maybe it? Did I recompile? Not sure, right? Let's retry that again. All right. Oh, that's beautiful. Okay, it was that I did not mark that as in out. Okay. Everything makes sense again. And now I have the vertices here, which are unique. But I still have not really a way to do the vertex. I mean, I guess what we can do is... So that's word count, which is at maximum 32. So we could do bool has visited of 32, which is basically all fours, which I think we have somewhere something similar already. Not quite sure where, but we do. I think somewhere down here. Let's remove that. Oh, here. I mean, we could as well. Why do we not do the vec Our vertex triangle fan in here. We could accumulate that already here. Basically every time we add one, we could create our triangle fan, right? That would work. Maybe not. I don't know. Does that make a whole lot of sense? Maybe not. Did I remove all the debugs? No. Alright, but yeah, we can basically take that, put that here. I think we don't need 32, but I don't know. So how many is that? 1, 2, 3, 4, 5, 6, 7. 7 times 4, 28, right? So if we do 8, then that's fine, right? Then we have 32. Or 4 times 8. Yes. My math worked out. I'm not. If traced segment where vertex visited vertex, if visited vertex at vertex index, then we continue. Otherwise we do all of that. We say visited vertex index at vertex index equals true, and we do that, and we do and unique vertex count, unique vertices count. And that should do it, if I did not do a mistake. And with that, we should hopefully get a triangle fan that's in the center. I hope. Otherwise, everything I did was completely useless. It's beautiful. It's perfectly in the center. We did it. We still have weird triangles, not gonna lie, but we might filter them out later. I wonder where they are coming from. Do I maybe need to do a +2? Do I maybe need to do a +2 here? Or something like that? Because it's adding like that. I mean, maybe. What does he do here? So he does that. And then he generates. And then if O plus 1 is less than 0, else. Ah, that's a transitional vertex. We don't need that. I think. Yeah, I'm not sure. Not sure about that. I think we don't. Although, wait, maybe. It's not I mean, it's not really an issue. I just noticed that I have like here this triangle that you can see now here, the vertex. That's like a degenerate triangle because it has a size of 0 basically. Because we have the same two vertices here. And then the triangle fan. So I'm curious if I just skip those. Or something like that. And it's mostly the fact of how I do this loop here. I wonder if it should be something like that we do really a vertex index plus plus here as well. But that might... Maybe that goes wrong? I don't know. Maybe we skip the last vertex then? I'm not sure. Let's see, what does RenderDoc say to that? So we have this triangle, and then we have this triangle, then we have this. And then we have a bunch of zeros here. Which kinda makes sense because we only need like, yeah, those triangles here. So where do those come from? It's because I reserve here that. Which is because it's 7 times 3. Yeah, probably it shouldn't be 7. Maybe it should be... If our vertex... If the vertex is the last one, maybe we don't do anything. Would that work? Maybe. But yeah, let's not deal with that. Let's not deal with that. Let's actually just keep it as is for now. It's a thing that we can investigate. Does he serve as well? Oh, okay, well he doesn't really because he has it different. This one handles it a little bit different, right? Because it creates triangles right away. Oh well, let's not deal with that, as I said. Alright, let's see if we can do the change to the octree so that we tomorrow have like the generation here done. And the change to the octree is that I want a separate list basically. So we have the leaf list here. But I think I as well want so that's a little bit of a question. How do we want to do that? But basically this would be word chunk. Or do we go back to the... Let me think. Either we go back to the way that I initially planned it, and then for simplicity I went away from it, which would be that those are the leaves at like a maximum size or a minimum size. And then we subdivide those basically manually again. Maybe we do that. Maybe we do that. Because then the only thing we need to change... I mean, basically that stays all the same, right? Question is what do I want to abstract out here? Because all of that would stay pretty much the same. That would more or less stay the same as well. So the only difference is the min size that I want to subdivide to. Which is basically this max depth here. Yeah, probably. Yeah. Well, and the start is a little bit different. Although, is it? I mean, maybe not, right? Because we could just initialize that with 0, 0, and then that's the leaf, basically. And from that point onwards, it's fine anyways. Or how do we do that? Here we get the root thing. And then it wouldn't be the root here because we get a depth, I'd assume. Well, okay, yeah, that's a little bit. Oh, I see. Okay, okay, okay. This currently works because of how we subdivide it. Yeah, I think we would then limit this again. Yeah. So basically this word octree only goes down to a size of 64 meters at max. And then we kick off here subdivision for fine grained voxels. Because all the others, they can stay the same. Yeah. So basically, I mean, we can probably, for now, for simplicity, probably do everything still in one. Chunk are all leaf nodes up. Well, leaf nodes greater than 64 meters or branches at 64 meters resolution. And that would basically be word octree chunk node or word octree chunk. Not sure. Well, let's word octree chunk node. And we do here, we do need the Morton here, we do need the depth here. Do I need more? Do I need a pointer to my parent? Or do I need a pointer to my node here? Probably not. Probably that's fine. It's a little bit of duplicated information here, which is currently a problem, I would say. That is definitely something we should look at, how we improve that to not have duplicated info here. I mean, do I need that? It probably helps, it makes it faster, I think. Because those would hold. Okay, yeah, so maybe that is actually not. Maybe that's actually not correct. Probably a word chunk octree should be something like that. Where basically we have either that or this, and this points to mesh buffer. Maybe. Would that work? Because basically I want every chunk up to a size of 64 meters to have its own mesh, so that we can easily regenerate only the parts of the mesh that need regenerating instead of the whole thing. And I think the plan was for this to be that thing. But how would that work right now? Because we currently only iterate over those nodes. Which don't have any information about their buffer or anything like that. Oh, that will be interesting still. How we do that. I guess what we could do is, if we don't subdivide, then that whole node can run a generate mesh shader, right? The only thing is if we want to subdivide from 64 meters, then we would want to subdivide for that thing on that count. That is a little bit not problematic, I would say, but yeah. Because we, I mean, I guess I kind of need some sort of allocator then. And we don't really... Do we care that it might be fragmented a little bit? Maybe not. Or do I find a better way to do it? I don't think there is any better way. But yeah, then the word octree would basically be chunk. No. God damn it, what is it called? Terrain? No. Chunk? Oh my god, what is it called? Terrain? No. Systems? Volume terrain system. Of course it is. So basically... So that's the root size, which is 65,000, and we want to get... Well, that divided by this is our node extents. So if I multiply that over and then so that's the depth size. So if I multiply that over, I want to find out the depth, right? So then that would be node extents times 1 shifted by depth is root size. And then I want root size divided by node extents is 1 shifted by depth. But then I still need to find out how much it's shifted, right? Because if I just do const expr Onyx F32, let's do that. Then I said root size, which is 1 shifted by 16 divided by 64f. That's like 1024, which is not what we want. Is that a log 2 then? No, right? Or maybe it is. 1 shifted by 10. Yeah. So that would be that. Man, my math is actually not so stupid after all. Where is my music? Okay. We will keep going a little bit today because I started a little bit late. But yeah, so basically the max depth would be this. Which is our root size divided by let's do a const for that for now. Const Onyx F32 chunk size. And with that, we should stop at depth 10, which now will, of course, look a little bit sus for our sphere, which we actually don't have, so we need to actually bring it back. And then let's kill our shaders again. And let's regenerate. So how shitty does that look now for the sphere? Probably quite bad. Oh, actually not too bad, but yeah, definitely a lower resolution here, right? Which is fine for now. Maybe we do the edit already and then we add back the detail. That would be as well a possibility, right? Although that small sphere we wouldn't see, I think, but it's fine, we can make it bigger. Max depth. I mean, maybe we actually save that. Wait, max depth. Why not? Is there now one less than we would want? Probably, right? I think that's even one dispatch lower. Oh. We should be able to fit that in there. We cannot fit more than 255 levers anyways in any decent system. Yeah, okay, that is what I thought. So we probably need to do that. Yes. All right. Perfect. So we do all of that, which we build here, and then we build chunks, chunk octrees. Which is basically compute command buffer, generation component, terrain word octree. Maybe. I mean, basically that would be update. Update or build? Yeah, whatever. Doesn't really matter. And we kinda use the same thing, so that's why I'm a little bit... Maybe we reuse some stuff here. Let's first build it and then we clean it up, right? And do maybe some refactorings where we can reuse stuff. That is basically here, build chunk octree, where basically we continue the subdivision, where we basically say, okay, this is basically max depth of whatever. I mean, that is probably depth of the terrain word octree max depth is the start depth. We don't have a chunk size. We have the root size still the same. Well, sorry. This is depth here. But probably we actually... Well, we probably don't do this. So we continue here from this to max depth, which max depth, which would be this calculation again. Oh, that is already the depth. Interesting. Okay. We will deal with that. So basically we don't need that. That is our resolution, which is 0.01. And then this divided by that log 2, which would be God damn it. Or the 65,000 whatever. 65,600. No 55, right? 5536. Divided by 0.1, which makes it bigger. And then we take the log 2 of that. Is that correct? Maybe? I mean, that looks kinda right. Not quite sure what that depth here is. Why do we have 2 times the depth? Did I already do the max depth and it's just that I'm stupid and can't remember? I have a depth and a max depth. Okay. But why was that 20 here? I mean, then... Okay, maybe then this was the depth and we just do that. Well, in this case we don't do that, sorry. Here we do that. And this is here that and here that. And then here we basically do const u8 max depth is this. No, is this. And that's the max depth. The start depth is this depth. Yeah. Do we seal here? Because that's a diff, like, maybe. Because that can be a odd number. Depending on the resolution. So we might want to seal here. Alright, and then, I mean, the push constants kind of stay the same. Can do that. So that's this, that's the leaf node buffer, that's fine, I think. We put in here the depth. Wait, then that's wrong. But did I fix that already again? Up here? Oh yeah, I did. So the depth we will set, the max depth we can set here. We don't do... I mean, we can do that down here. That we don't set that. Do we need to set that? Yeah, because we swap it, right? Yeah. Root half node extends we can kill. Offset we don't really use, I think. And now we continue that. And then the only change we need here is that if we are at the max depth, we don't add ourselves to the leaf list, maybe? So if, well, if we want to split is chunk max depth. It's basically if our depth is the max depth and depth is 10. Otherwise, if we are a leaf fully, we subdivide. And then here we do... Well, actually, hold on. We don't need that check here. We need that in the evaluate octree node. Bool is max depth. It's basically that. Is chunk max depth. Is that equals 10. And then if is max depth. And is chunk max depth. Well, or... yeah, okay, that doesn't work quite as I would want it to work, right? Or does it? Maybe equals force. Maybe we need that. So that we don't do that part. I think that might be it. That might be subdividing again further. Potentially. Or maybe not. I don't know. We will find out, I guess. The hard way. Generation component. What do I need that for in the other case? Oh, because we need to... Yeah, we need to bind the shader effect. Do I need to bind the push constants? No. But here we should bind the shader effect again, just to be sure. Again, we might split it into 2 shaders. Oh, that worked great. That exactly worked as planned. Not. Oh, maybe... Maybe it's because we don't know which buffer is which. Could that be it, that it needs to be something like that and then it works? Okay, maybe not. Oh wait, I mean, probably we are not allowed to do that. I mean, we could, but we shouldn't probably. Okay, maybe not. Oh no, we actually bury it here anyways. Okay, never mind. So that's probably not it. Let's see, do we even get in here? Is the other point right? Okay, we do get in here. And max steps 20 looks fine. While that is garbage, we should probably do +1. And then we are here. Perfect. So we have the chunks in theory here, and then we have the chunk trees for the higher like subdivision here. So that's already good. The only thing is we need to save the chunks here out. So that those are not I mean, they are leaves. As well, potentially. But it should be separated. But we will do that, I think, tomorrow. And the idea probably would be that we have a list of active chunks, maybe. And that's the index. Maybe index into octree buffer. And then that one stores the voxel thing, and the voxel offset goes to a struct that is the Morton and depth info. Or that could work. And then if that one has, if that active chunk is further subdivided, then I have no idea yet how to do that. But do I need that? Maybe not, right? That could be really the index to leaf structure. structure. I maybe not, because we could have 6 different children, right? Yeah, I think I have to think about that a little bit more, but I am super hungry. So I think I will call it a day. But we fixed like the vertex position today, which is nice, and we split our octree into like 2 stages, which is the first way to get to the chunks. Now the only question is how we store it efficiently, or like somewhat efficiently. Maybe, yeah. No, yeah. Let's do that. Let's figure that out. And then with that, we should be able to now regenerate the octree based on chunks, as well as hopefully do the edit in like a very, very fast way. All right. But thank you very much for joining. We will see each other tomorrow. Tomorrow I will be punctual and not like today. But I was like almost falling asleep. Yeah. Have a great rest. What's up? And yeah, hopefully we see each other tomorrow again. Or hear each other tomorrow again. And yeah, everyone else as well. Thank you for joining. See you hopefully tomorrow. Bye bye.